Hello students, today's topic is elimination reaction and its type. First, myself, Sangeetha, Department of Pharmaceutical Chemistry, Vinayaka Missions College of Pharmacy. Welcome to the wonderful world of chemistry. My dear students, do you think we can live without chemistry? It is impossible. The chemistry is merged with us. The air what we inhaling is oxygen, isn't it? From which we can able to say how important is chemistry to our life. For the past 2 years, our world is struggling due to pandemic. The situation is now changing little bit. Because of what? Because of the main reason is vaccine. So the vaccine is nothing but a chemical, a chemistry. So the chemistry is a very interesting and very important topic for our life. Okay students, let's play chemistry. Our topic today is elimination reaction. First I am going to discuss about introduction, and then I am going to discuss about the classification of elimination reactions, mechanism of elimination reaction. First we are mainly focusing on that is E1 and E2. It is nothing but unimolecular reaction and bimolecular elimination reaction. My dear students, what is elimination reaction? Elimination reaction is nothing but the term itself indicates what is elimination. It is going to remove an atom or a group of atom from a molecule. So something is going to be eliminated, right? So it is called as elimination reaction. So the elimination reaction, what is going to happen? We are going to remove an atom or a group of atom. Okay. So then what will happen if you remove an atom or a group of atom? Definitely the single bonded compound is going to converting into a double bonded compound. So the single bonded compound is going to convert, that is saturated compound is going to converting into a unsaturated compound. That is the main idea of the elimination reaction, and by which the preparation of alkenes is being done by this elimination reaction. So the elimination is a type of reaction mainly used to transform the saturated compound into a unsaturated compound. It can be of double bonded or triple bonded. Okay, elimination reaction of an organic reaction, what I said before is that is the right. Okay, so when two atoms or a group of atom, it is going to be removed, okay, with being replaced by the other atom. It is not going to be replaced. Without replacing, the particular reaction is what is happening. We are going to eliminating, we are not substituting. The total atom or a group of atom is being removed or eliminated. It is not going to be substituted. That you have to understand. Okay. So elimination reaction is a type of organic reaction in which two atoms or the groups are removed from a molecule without, that is important, without they are being replaced by other atoms or a groups. Okay, we are not going to replace it. Okay, resulting in the formation of a multiple bond. So it is going to converting into a unsaturated compound. In the great majority of such reaction, the atoms or the groups are lost, okay, from the adjacent carbon. If the carbon is there, from the adjacent carbon it is going to be removed. Maximum the removal from the what will be removed? The removal will be the elimination will be a proton. Okay, the proton is going to be removed and a good leaving group is going to be removed. Okay, what they are saying, there is any confusion in that. It is going to be eliminated. What is going to eliminated? The atom which has been attached with the carbon is going to be eliminated. It can be a proton and it could be a good leaving group. Okay, next, it is a type of a chemical reaction. Okay, normally the elimination reaction is not taking place in normal conditions. It is going to be taking place with the help of a acid, base or a metal, or in an extreme condition the elimination reaction is going to be taking place. Okay, so the elimination reaction is not taking place in the normal situations. So with the influence of acid, base or a metal, okay, by which or by using a high temperature it is going to be taking place. So first I have said the saturated compound is being converting into a unsaturated compound, right? So the saturated compounds will be what bonded? Sigma bonded. The sigma bonded cannot be easily broken, right? So by using an acid or a base or using extreme conditions by heating, then only the sigma bond is going to breaking, right? So such condition has been taking place in elimination reaction. So saturated compound is going to be converting into a unsaturating compound. In that the elimination reaction is carried out with the help of acid, base, metal, or by using a high temperatures. Okay. Normally the elimination reactions can be classified based on what is going to be eliminated, by which we can able to classify it. Okay. So what they are saying, if the elimination is a water molecule, then we can say it as dehydration. That is there, right? So normally the elimination reaction is distinguished, that is classified by a kind of atom or a group of atoms that leaves the molecule. So from a molecule, if the atom or a group of atom is removed, by which we can able to classify it. Due to this, there are two methods are involved. First is dehydration and dehydrohalogenation. What is dehydration? Dehydration means removal of water molecule. Dehydration means what? Removal of water. Dehydrohalogenation, D itself indicates that something is going to be removed. What is going to be removed? Dehydro. So definitely hydrogen is going to be removed, and halogenation. So halides, so HCl, HBr, HF, HI, like that it is going to be removed. That is known as dehydrohalogenation. So what is going to be removed, by which we can able to classify it. So what they are saying, normally the elimination reactions are distinguished by a kind of atoms or the group of atoms that leaves the molecule. Okay. So it can be of two types. Based on the elimination, it can be classified as two types as what? Dehydration. Dehydration means what? Removal of water. Dehydrohalogenation means removal of hydrogen halides. Okay. What is going to be taking place in elimination? What is the fundamental events, or what is going to happen step by step? First, proton removal. In elimination reaction, first what is going to happen? Proton is going to be removed. Okay. First what is happening? Proton is going to be removed and carbon-carbon pi bond is formed. That is what is happening. Double bond or triple bond is going to be formed. First what is happening? Proton is being removed. Okay. Next, carbon-carbon pi bond is being formed. Okay. And there is a breakage in the bond of a leaving group. The compound which is going to be eliminated, it is going to breaking its bond. That is, the three important steps will be taking place in the elimination reaction. First, proton removal, and next is what? Carbon-carbon pi bond will be formed. The double bond, that is, the saturated compound is converting into a unsaturated compound. Then there is a breakage of a bond of a leaving group. The compound is going to be eliminated, right? In that leaving group is going to break its bond. Okay. Next, okay, depending upon the reaction of the, that is reaction kinetics, based on the kinetics it can be also classified. Based on the elimination of a, if the compound is water is going to eliminate it, it is known as dehydration. The hydrogen halide is removed, it is known as dehydrohalogenation, by which we can able to classify the elimination reaction into E1 and E2 based on the reaction kinetics. Based on the reaction kinetics, okay, by them it can be namely classified as E1 reaction and E2 reaction. It is very, very important. In case of E, what it represents? E represents the elimination and the number represents the molecularity. The number represents the molecularity. 1, which is nothing but uni. 2, it is nothing but bimolecular, unimolecular. So what the E1 stands for? Unimolecular elimination reaction. What is E2? Bimolecular elimination reaction. So in this video we are focusing on E1 and E2 reaction. Okay. Next we are going to discuss, that is we are mainly focusing on today's video is what? E1. Yeah, E1 and E2. So in E1, what does E1 stands for? What the E1 represents? Unimolecular elimination reaction. So in the E1 mechanism, that is refers to be what? Unimolecular elimination reaction. So it is two-step mechanism. It is what? Two-step mechanism. So the important aspects. So if you want to undergo a unimolecular elimination reaction, what are all the important criteria? What we need is, we requires a weak base, okay, and a protic solvents. It is going to be taking place in the aqueous solvents, okay, aqueous solvents, but in the weak base, okay. So what the E1 stands for? Unimolecular elimination reaction, and it requires a weak base, and it is going to be taking place in a aqueous medium, and it is a two-step mechanism. The reaction will be taking place in two steps, step 1 and step 2. So it is taking place under two steps. The step 1 is ionization and step 2 is deprotonization. Step 2 is what? Deprotonization. During the ionization, definitely there will be a formation of carbocation. The intermediate will be formed. So definitely due to the help of a base, the deprotonization, automatically the proton is going to be removed. So what is happening? It is going to be taking place in the presence of a weak base. The reaction is going to be taking place in the presence of a weak base, by which we are going to form a pi bond. Okay. The rate of the reaction in E1, the rate of the reaction is directly proportional to the concentration of the substrate. It is definitely depends only on the concentration of the substrate, that is single substrate. So it is called as unimolecular, and the rate of the reaction is also what? It is under what kinetics? First order kinetics, because the rate of the reaction depends upon the single moiety. So it is called as first order kinetics. Okay, so we can go for the reaction. So we are going to take a alkyl halide, that is particularly we are been taking what? Tertiary alkyl halide, that is tertiary butyl bromide is been taking. Okay, in this it has been taking place in the aqueous medium. It is going to be taking place in the aqueous medium. Automatically there will be lots and lots of what? Hydrogen will be present. So water molecule will have H2O, right? In that we have lots of hydrogen. Definitely this hydrogen and bromide, H plus and Br, it is going to be removed. Definitely it forms a carbocation. When it is bromide is being removed, automatically it forms what? Carbocation. The positive charge will be formed. So this carbocation, it is going to be reacting with what? A weak base. We are using a methanol. For example, we are using methanol or ethanol. We are using any alcohol, that is a weak base. When this weak base is being attacking this proton, automatically this is a base. It is, that is OH minus. It is going to be what is happening? It is going to be attacking the H plus, that is proton. It is going to be attacking the H, okay, that is proton. So and the step 1 is a slow step. It is a rate determining step. It is a slow step and it is a rate determining step. So the carbocation formation takes some time, because the cleavage of CBr bond, it will be taking place slowly. So it is a rate determining step. So the cleavage of CBr will take some time, and it is taking place in the slow step. It is a slow step. So when this carbocation is being formed in a aqueous medium, okay, the whole reaction is taking place in the aqueous medium, and so this CH3 can be written as what? CH2 and H. So it can be represents what? CH3, right? In order to understanding, I am writing as what? CH2 and H. So when this base, that is OH minus, it has been attacking the H plus, that is proton, automatically it is removed as what? It has been removed. So automatically this bond comes here. So it is forming a alkene, double bonded, that is single bonded compound has been converting into a double bonded compound, that is isobutylene has been formed. What is forming? Isobutylene. butylene. So in step 1, the first is what is removing? CBr bond, that is Br, it is being removed, the halogen is being removed, and the second step, the first step is a slow step and it is a rate determining step. And step 2, the weak base, that is for example we can take ethanol or methanol, the OH ion, it is going to attacking the proton of our carbocation that has been attacked and that has been removed, and definitely there will be a formation of a double bond, that is saturated compound is converting into a unsaturated compound. Okay, next we are going to discuss about E2 reaction. E2 represents what? Bimolecular elimination reaction, and it is one step mechanism, and it is a one step mechanism. It is going to, here what is going to happen? Carbon and hydrogen and carbon and halogen bond is going to be breaking off to form a double bond, but it is that two breaking down is being taking place simultaneously. It is going to be taking place simultaneously. However, E2 mechanism, that is the E2 reaction depends upon the concentration of the base as well as the concentration of the substrate. So it is called as what? Bimolecular elimination reaction. So it is called as what? Bimolecular elimination reaction, because it depends upon the two molecules. So it is known as bimolecular, where in case of E1 depends upon only the concentration of the substrate, that is single moiety. So it is known as unimolecular. But in case of E2, the reaction depends upon the what? The reaction, that is, it depends upon the concentration of the substrate as well as the base. However, in E2 mechanism, a base plays a rate determining step, and it is a huge influence on the mechanism. That base plays a huge, because we are using a strong base. We are using a strong base. So it plays a influence this reaction. So it has been taking place in a single step. Okay. So what is happening? Here we are taking a alkyl halide of any degree. It can be of primary or secondary or tertiary. For example, we can take a tertiary alkyl halide, same what we are using in E1. We are taking a alkyl halide. It consists of what? Alpha carbon and beta carbon. We all know what is alpha carbon. The carbon, when it's attached with the functional group, that carbon is known as alpha carbon. Adjacent to alpha carbon is beta carbon. Now what is going to happen? We are using a strong base in a non-aqueous medium. We are using a strong base in a non-aqueous medium. Okay, so we are using ethanolic KOH. We are using ethanolic KOH. This is the alkyl halide. This is alpha carbon and this is beta carbon, and we are using ethanolic KOH, that is strong base in a non-aqueous medium. Okay, now this, what is happening? Now the base is going to attack our proton, but the attack is going to be taking place at the backside attack. It is the carbon, the base is going to attack at the carbon at the backside. Why? Why it is not attacking straightly? Because it is a strong base. Definitely this is also a halide and that is a OH. Definitely OH minus and X minus. Definitely there will be a repulsion will be taking place. What is happening? Repulsion will be taking place. So definitely in order to the reaction should be carried out, automatically what is happening? The strong base is going to attack the carbon at the backside because of the halide ion is present here. So definitely there will be a repulsion. So there is a backside attack is going to be taking place. Now this carbon is going to attack, the base is going to attack our proton, right? So automatically what is happening? The halide ion is also to be removed simultaneously, which has been taking place in the same step. In the single step, what is happening? The base is going to attack, at the same time the halide is going to be removed. So it is taking place in a one-step mechanism. It is a one-step mechanism, and this is the transition state. So it is going to be removed, and this is also going to be removed at the same time. This is known as transition state, from which we are going to form, when this halide ion has been removed and HB is also been removed, automatically there will be a formation of a double bond. There will be a formation of a double bond is going to be taking place. So the E2, that is the B represents base and X represents the halogen. So it has been taking place in one step. At the same time, that is H and B, that is proton and base is going to be removed, and halogen is also being removed at the same time. So it is known as what? E2 elimination reaction. So the rate of the reaction will depends upon the concentration of the alkyl halide as well as the base. We are using a strong base and a aprotic solvent. Okay. Now we are going to distinguish E1 and E2 reaction. So the rate of the reaction will depends upon the concentration of the substrate. The rate of the reaction is going to depends upon the concentration of the substrate. So it is called as unimolecular. So definitely you have to understand what the one indicates. The one indicates that the rate of the reaction will depends upon the concentration of the substrate only. So it is called as what? E1 reaction. Where in case of E2, the rate of the reaction will depends upon the concentration of the substrate as well as the base. So it depends upon the two molecules. So it is called as bimolecular elimination reaction, and it is two-step mechanism, and this is one-step mechanism. What is the step 1? Ionization. What is step 2? Deprotonization. What is step 1? Ionization, and step 2 is deprotonization. So ionization will be taking place, and the step 2 will be deprotonization. The proton is going to be removed, and here it is one-step mechanism. Here that is carbon and halogen, and carbon and hydrogen going to be removed simultaneously. So it is one-step mechanism. The most preferred alkyl halide is what? Tertiary alkyl halide. Next is what? Secondary, and then it is primary. This is the order of preference, and there is no any preference. We can use any alkyl halides. Then we are using a weak base. Okay, we are using weak base in a protic solvents. We are using a weak base in a aqueous medium, and we are using a strong base in a non-aqueous medium. That is very, very important. And we are using what? First order kinetics, because the rate of the reaction depends upon the concentration of the single moiety. So it is what? First order kinetics, and this is what? Second order kinetics. It depends upon the two molecules. So it comes under second order kinetics. General recalling, what is the elimination? We are going to eliminate an atom or a molecule. Okay, we are going to remove an atom or a group of atom from a molecule. Definitely there will be a formation of this saturated compound is going to be converting into a unsaturated compounds. So it can be classified based on the removal. It can be of dehydration or dehydrohalogenation. What molecule is going to be removed, by which we can able to classify. Then based on the order of kinetics, whether it is first order or second order, we can able to classify it as what? E1 reaction and E2 reaction. E1 is nothing but unimolecular elimination reaction. In that, the overall reaction will depends upon the concentration of the substrate. So it is called as unimolecular. The rate of the reaction will depends upon the concentration of the substrate, and it is two-step mechanism. One is ionization, and next is protonization, and next the most preferred degree of alkyl halides we are using is tertiary, then next secondary, and then primary. We are using weak base in a what? In aqueous medium. We are using a strong base. Okay. In case of E2 reaction, what does E2 represents? Bimolecular elimination reaction. So the overall rate of the reaction will depends upon the concentration of the substrate as well as the base, and it is a one-step mechanism. The elimination of both hydrogen and halogen will be taking place simultaneously with the help of a strong base in a non-aqueous medium. There is no such preference. There is no degree of alkyl halides. It can be of any degree of alkyl halides we can use for the E2 reaction, and it carries out what? Second order kinetics. It is a very, very important exam point of view. It is very, very important. What is elimination reaction? What is E1 reaction, E2 reaction? How it is been? What is its mechanism? It's very, very important. So I have go through this E1 and E2. Thank you for watching my class.